severed leg, and they're like, yeah, just walk it off.
Exactly. Walk it off.
It's true, man. That's cool. I don't give a crap.
Yeah.
All right. Let's try to do as many examples as we can before time runs out. I won't be able to get to everything, but I'm going to try to give you. I already made the test, so I can at least give you hints now. Yes.
So for homework,
Uh-huh.
I think it's 5.2. You said we don't have to do like the 63 to.
Yeah.
Okay.
Indeed.
Oh,
There's a few homeworks problems that said you don't have to, you can skip. Like, what section was it? 5.2?
I think it's 5.2. Yeah.
60. I mean, it's in the notes. I forgot what it said, but skip 61 through something, and I forget.
I have a question. We haven't grabbed the trigonometric function like sine and cosecant.
Are you asking me on the exam?
Yeah.
No, there won't be no graph.
Okay. I think it's-
5.2 is 53 through 62 that we don't have.
yeah.
Thanks. Okay, so let's get started. Well, you have at least one combine the logs. This one has numbers in it, so let's go ahead and do this guy first. Before you can combine anything, we said you have to bring the powers, right? So that was the power rule. And then if you square the 7, that's just 49. Now, product rule says multiply these. Which will give us 294 is what I got earlier. Any questions on these steps here? So we brought up the 2 as a power. We applied the power. We then use the product rule to combine the 2 logs, and then we multiply it. You guys okay on number 1? All right, let's do another one, this time with a bunch of variables. 3 ln 2 plus 2 ln x minus 1/2 ln x plus 4. So first thing, I bring the powers up. So that is the power rule, just like before. Okay, at that point, combine them 2 at a time to be safe. If you want to do all at once, that's on you. Just don't mess it up. 2 cubed is 8. So I'm going to combine the 8 and the x squared. And then I'm going to do the square root next. 1/2 power square root. Combine into 1 logarithm, and you're done. Any questions on example 2? Is that okay? Okay, let's do one more combination of logs and then we'll move on to equations from 4 to 5. All right, you guys cool on this page? All right. That's okay. Example 3, one more combination. So 2 times everything, log 5 of x plus 2 log 5 of y minus 3 log 5 of z. So all the bases are 5s. My z's have lines through them because they look like 2s. So 5 base and a z. All right, so first thing we should probably do is distribute the 2. You could work inside first if you wanted to, but it might be easier to get that 2 in there. So you're going to get 2 log 5 of x plus 4 log 5 of y minus 6 log 5 of z. So at that point, bring up the powers, because now we have new coefficients. This would be log 5 of x squared plus log 5 of y to the 4th minus log 5 z to the 6th. That's a power rule. I don't know why I did that. Not thinking straight. Haven't finished. What's the next step here?
Product and quotient.
Let's combine these two. And then do the quotient.
You could just like skip that step, but if you want to do it, but then you have to show that.
Show what?
You have to like show those 2 steps, or can you just like already put it at the product?
This one.
That's what I'm saying. Like you can do it all at once. I do it piece by piece so you can see it, but also to make sure we don't mess it up. So if you do it all at once, don't F it up, right? It's on you. Someone else have a question? So there's a y to the 4th, y 4th, x squared, z6. So this will be on top. This will be on bottom. Any steps that don't make sense?
I thought that was a 4 in front of the 5 instead of a Y.
This one is a 4, yes.
No, the one in the print.
This? These are Ys, yeah. Okay. So you guys are good on number 3.
Yeah. Which, okay. Okay.
All right, let's move on to 4, 5 then. E to the negative 3x is equal to 10. Start with something simple. We have to solve for x. I recommend when you see an e, try to keep. I mean, I think you should use ln all the time, but for sure when you see an e. So first step is introduce ln on both sides. These will cancel because they are inverses. You get negative 3x equal to ln 10. Then divide by negative 3, and you're done. X is a negative ln 10 over 3. So when you divide a positive by a negative, the whole thing is technically negative at that point. So you put the minus in front, you could leave it on the bottom, you could put it on the top, it doesn't matter. It's all the same. Just don't put it in both spots, right? 'Cause then they would cancel and it wouldn't be negative, right? So you can choose one, doesn't matter. Those are the rules. Any questions on 4? Seem doable? All right, let's do another one that's harder to.
Yeah.
Wait a bit.
I can say. I can say. I was just thinking about courtesy for people trying to-
You guys good? So if you see equal signs, that should be a hint that you're solving something. When you have an equation, I should say, solving for something specific. We want to know what x is. So in order to solve for x, we have to bring that power down, which we need the property of logs, right? 2 to the 5 minus 7x equals 15. So just introduce ln again like before. You could use regular log if you want. Then you bring down the power. Now I want you to make sure when you bring down the power, you put parentheses on the power you brought down. Because notice, if I don't put parentheses right now on the 5 minus 7x, it looks like the ln2 is only on one part, right? See how that would be a mistake. So make sure when you bring something down, it's in parentheses, right? The whole thing is on ln2. So don't make that mistake. I know someone's not going to listen, but someone always does that on the exam. So distribute ln2 to both of these. You could technically divide the ln2 here and make it a little easier, but later it'll be more complicated and it's not gonna be easier. So might as well just do it the long way. So I'm going to distribute the 5 on the ln2 and the 7x on the ln2. Remember, this is just some number that nobody cares about. So this number times these two things. So multiply and distribute. That makes sense? Like if you had a, I don't know, x plus 3, and there's a 2 out here, you would distribute the 2. It's just on the right side. Usually we see it on the left. So if that bothers you, just remember it's the same thing. Anyway, once you're here, isolate the x part. Move everything else to the right-hand side or the other side. So I'm going to subtract 5 ln2 on both sides, which will give me ln15 minus 5 ln2. All right, so there's a -7 and ln2 on the x, so just divide by these two numbers. Don't let that bother you. All right, so we're dividing by the -7 ln2, because I want that cancel to isolate x. This side will have -7 ln2. So x is equal to whatever this is, some decimal. Any questions on the steps? Okay. Got school on number 5 then. All right, let's do something a little harder then. I'm not gonna ask you to give me an approximation. I'm just gonna ask you the exact. You know how in the homework they're like, oh, what's the decimal form? I'm not gonna ask you about decimals. Just this. And you can write these many different ways, right? You could polish this off a little bit more, but you don't have to. I could bring that 5 up, I can combine the log, I can make it look a lot prettier. But you don't have to. That's cool on this page. All right. This one is an example where you have to distribute. So introduce ln on both sides. Bring down the powers, but put them in parentheses. Okay, so at that point, distribute your ln2, distribute your ln3, and then get all the x's on one side, all the constants on the other side. So 3x ln2 plus ln2 equals x ln3 minus 2 ln3. So this guy, these have x, right? Get them on the same side. Doesn't matter what side. Gonna move this guy over here. This is how I like to think about it. I'm just moving things to the opposite side. But that's not legit math. And technically, you'd be subtracting both sides by this term, right? But I like to think about it as I move it over, so I change the sign. Don't move that guy over here, change that sign. Keep it simple. So now I have all the x terms on the left. So at this point, you have to factor, because you want to isolate x. So at that point, just divide this off, because this is just some weird looking number. Just get rid of it, and you'll have x. So divide both sides by this thing. And you can put parentheses or not, it's not good. So these are gone. So x equals this weird number, which can be written a little prettier, but we won't, unless you want me to. Any questions on any of the steps? Is that doable? Let's move on to log equations then. So when you solve for log equations, you have to test the solution. You don't have to test on exponential, but you do on the logarithmic. You guys cool on this page? So when you're solving for a log equation, you want to combine all logs before you cancel or try to cancel anything. The first thing is combine this side using your product. So that'll be x times x minus 1 equal to log of 4x. That'll be log of x squared minus x equal to log 4x. So just combine these two by multiplying. That's all we did. This is a product. Now, this next step may seem unnecessary, but I want you to do it this way all the time because there's certain examples where it'll be easier this way. I'll show what I mean in just a moment. So introduce a matching base. See how they match up? Log base 10, 10. And notice how you end up just having the arguments equal to each other. So the question becomes, like, why can't I just set these arguments equal to each other? I mean, you can, by definition, but if there's no log on one side, then it's a little trickier. So that's why they're using this base will keep you straight. Okay, it'll work out all the time this way. And I'll show you in the next example what I mean, but for now, these are the steps. Introduce the base to cancel whatever we're talking about, and then solve for x. So I'm going to subtract this guy. Okay. So we got x equals 0 and x minus 5 equals 0. So x is 5 and 0. And am I able to use both of these solutions?
You don't forget.
Yeah. Gotta test it. So in the exam, if you just leave it like that and not tell me that, you better hope that they're both right. If it turns out one of them or both are fake solutions, you will lose points at that point. I'll give you something because it's still good work, right? But I do need you to test them. Now, if you kind of just eyeball it right now, plug it in 0. Am I able to?
No,
No, right? Why is that?
because the second one shows you a -1, you can't count it.
Yeah, this guy for sure, you get a negative in the log. But also, you can't plug in 0 anyway because the log is defined greater than 0. So 0 and negatives are not allowed. So right away, this should be a no. But let's say you couldn't see it. You say, I'm just going to test it because that's what they told me. Who cares? When you do this, you'll get a bunch of errors in your calculator. It's undefined as x equals 0. So do not include this. So most likely this one's an answer, but we still got a test. It is possible that you have, that both of them fail. So plug in the 5. Plug in the 4. Plug in, that's right, 5 minus 1 is 4. Okay. So log 5 plus log 4 is equal to log 20. Is that true?
Yes.
Yes, right, because of the product rule. So cool. So box your answer. We're not going to include 0. So as soon as you see quality, 100% convinced it's a solution. I'm 90% convinced it's a solution if I'm able to plug it in without issue. 90% of the time, just the fact that you can put it in there without any problems means it's going to be an answer. But this here proves it. This next line here. Any questions on example 7? Let me give you one more and then we'll move into chapter 5. You guys cool on this page? Does it make sense? Okay. Last log equation. Let me give you something where it's equal to a constant, so you can see what I meant earlier. Log x plus log x minus 3 equals to 1. So the first thing is use your product rule to multiply them.
Wait, what is it? A 1.
To 1. So at this point, we want to introduce the same base that cancels that log. This is a common log, so we need to introduce 10. So see how now it's going to be helpful to use that 10. Because I can't set this equal to that argument. There is no argument. This is why I recommend doing it this way. So the equation becomes powers. These cancel. So I have x squared minus 3x equal to 10. Now solve the quadratic. Is this factor pretty?
Okay, so where did 10 come from? That one doesn't come back in?
Yeah, the one's the power. Yeah, 10 to the 1 is just a 10, right?
This is the log.
Yeah, and we chose 10 because of the base, right? So if this was log base 2, then you would have 2s here. Yeah, I think you're right. So factors of -10 to add up to -3. Okay. Can I use -2? Now, right away, you should see it's going to cause problems, right?
Yeah.
And then this one, same deal. So I should not include that, but if we were to test it, we will see it. The calculator give you a bunch of errors at that point. Test the x equal to 5. So log 5 plus log 5 minus 3. Is that equal to 1? That'll be log 5 plus log 2 equal to 1. Log 2 times 5 is 10. These bases match, so 1 is equal to 1. So the only solution is this one. Any questions on number 8? You see how we showed, how we tested it, and how we found the two values. All right, that's all for chapter 4. Let's move on to 5.1. Now, I am going to ask you about reference angles and terminal points. You guys cool in this picture? So 5.1, this is what I need you to know. Find the reference angle. Part A is 5 pi over 6. Now, if you're it helps to have a visual.
Can you see that? Maybe she just has to- Okay. We could, set up a-
Can you guys see that okay?
Mhm.
So 5 pi 6 is 150, right?
Yeah.
So reference angle means, what is the angle between the angle in question and the x-axis? It must be positive, always positive. So 150 to 180, 180 is the x-axis.
Mhm.
That distance is 30. But we're dealing in radians, so 30 is pi 6. Now, if you needed to find it, since it's less than 180, all you got to do is subtract from 180 to find that difference. Like, let's say it wasn't a pretty angle. Let's say it was like, I don't know, 140 degrees, right? Or some weird pi angle like 3 pi 7ths, something like that. 3 pi 7ths would be somewhere in here, I think. But anyway, maybe not. But let's pretend we had an angle in here. What you have to do yeah, it's being weird. Okay. What you have to do is subtract from pi, even though we know the answer is pi over 6. The work you would show would be something like this. Get the common denominator. 6 pi over 6 minus 5 pi 6 is a single pi 6. For reference, I might be a little more cool about it. But if you get it wrong, then like there's no partial stuff to give it. You can, yes. That would be fine for a reference question.
I have a question. Why we are doing this since it is inside circle itself? Like, why can't I do like directly pi minus 5/6? Or no, I'm sorry. What is the reference for the first quadrant, the second quadrant?
Second
T minus
quadrant?
5?
Yeah.
Okay, so why don't I just do like 5/6 minus 5?
You can just make sure it's positive. Just fix it. Yeah.
Let's say it was like 8 pi over like 10 or something, would it end up being 5/8? But is it always end up like that? Or 5/8?
Yeah, you just got to get the same same denominator. You'll be fine. If you're in quadrant 4, you'll subtract from 2 pi because if you look at the circle. Like if you go all the way around and you're somewhere in here, subtract from 2 pi or 360 to get that distance to here. Okay. Excuse me. If you're in quadrant 1, well, it's just the number, whatever it is, right? No big deal. Quadrant 2, if you do the subtraction from 180, just make sure you make it positive because it would end up being negative. But there is no negative reference, so just take an absolute value. But I'll probably give you something nice like in quadrant 3 or quadrant 2 or 4, like this one. No thanks. Like this guy is in quadrant 4. So I need to subtract from 2 pi.
That's
7 pi fourths. So you take 2 pi and subtract 7 pi fourths. So 2 pi needs that common denominator. That'll give me 8 pi over 4 minus 7 pi over 4. Which should be 45 degrees, right? If you look at that circle, you'll see how far it is to the x-axis, right? 7 pi fourths, we're at 315. How much more until 360? Pi over 4, right? 45 degrees. Any questions on reference? All right, let's move on to terminal points then. Get school on this page. All right, example 10, still 5-1. Find the terminal point. Part A, this, I think I talked about this one in class. 800 degrees. Obviously, that's more than 360 degrees, right? So the question becomes, how many 360s are inside 800? Because those extra revolutions don't mean anything. It just matters where you land, right? So if you don't see it, just subtract one circle, see how much you get. What's 800 minus 360?
440.
That's still bigger than 360.
I would say 540, yeah, 800 minus 540 would be like 100.
Yeah,
160.
so still more so, subtract another one. So this is where we went. So we make 2 full circles and then go 80 more. So we are at 80. So the terminal point, the actual spot that you're on, is 80. Is there any questions on part A? So visually, (800 degrees) means I went around once, 360, and then again 720, and then I had 80 degrees left. So I'm about here. That's all. So those are in radians. The same question, are you bigger than 360, right? Or in other words, 2 pi. Because 2 pi is the same as 360. Is this more than 2 pi?
Should prefer A is 80 degrees is the answer.
Yeah. So I did this earlier. Five pi over 2 is 7.8, whatever. 2 pi is 6.28. So obviously this is bigger than a full circle, right? So subtract a full circle and see what we get. Just like before, this is the same as minus 360. It's just not in degrees. Same thing. Same thing. So get a common denominator. Five minus 4 is a single pi over 2. This is where you land. Any questions on that idea? Make sense? And if you look at it visually, pi over 2 is obviously half of pi, right? I know that sounds weird, but that's what that means, right? So 2 halves is a whole pi, correct? So pi over 2, 2 pi over 2s, 3 pi over 2s, 4 pi over 2s, 5 pi over 2s. So yeah, of course, it's pi over 2. Terminal point. You see what I'm saying?
I have a question.
Mhm.
Terminal point, we should write the x and y, like 0 and 1, for example, or pi over 2. Pi over 2, should we write this like 0 and 1?
Well, not for these questions. If they ask for terminal, just give the angle. When we get to the sine cosine stuff, then you'll use those. Okay. So I think 5.2 is all about that. Let's move on. You guys have any questions on 5.1? That's all I'm going to ask is terminal point, reference number. 5.1. 5.2 and 5.3 is really the same thing. I'm sorry. 5.3 and 5.4 is the same thing. That's all I want to know from those two sections is going to make register note. For 5.3, 5.4, because we're running out of time. Be able to find. Only thing I'm going to ask is period, amplitude, horizontal shift. Of sine, cosine, tangent, secant, cosecant, cotangent. So as long as you know how to find a period for all of those, period, amplitude, horizontal shift, it'll be fine. I'll probably have just one question about this idea. Okay. 5.2 though. Be able to use your circle. Unit circle. So for example, let's say, so we had make up a question, given theta equal to pi over 2, find sine, cosine, tangent at theta. So you just have to tell me what is the for sine, what is the y value at pi over 2? What is the x value for pi over 2? 100. What is tangent of pi over 2? Yeah, it's going to be undefined, right? So something like this is what I'm going to ask from 5.2. Nothing else. Just understand, like, how do you find the sine of an angle, cosine of an angle, tangent and secant? All those are fair game. Okay, you know what I'm saying? So just in case you're lying to me.
Is there any question about the range and the similar range?
No, but it might help to understand sort of like that log question. So sine of 2 pi thirds would be the y value. Cosine of 2 pi thirds is the x value. So you just write down the x, write down the y. Yeah, tangent, you would divide y over x. So you would divide square root 3 over 2 by negative half. And simplify that, and that would be tangent. So remember, so you're going to have to know what's the definition of sine, right? That's the y value. Cosine is the x. Tangent is y over x. What is secant? What is cosecant? Right? Secant is what? 1 over x. Right? Cosecant is 1 over y. Cotangent is the opposite of tan. So, yeah, x over y. So I have that all in your formula sheet. So you can just pick it off the circle and just divide them. Question?
What was the formula again? You said
Sine corresponds to y value. Cosine corresponds to x. Tangent corresponds to y over x. Secant is 1 over x.
We can have all this on the formula.
Yeah, those definitions are fine. They should be on there.
1 over.
Yeah, secant is 1 over x. Cosecant 1 over y. Cotangent is x over y. So in this example, we just did sine, cosine, tangent, but I could throw the other three at you, or one of the others. It's all fair game. Five, I think is the only section that's a little difficult in chapter 5. I feel like the rest is pretty chill. You might disagree. I don't know. Might have time for 5-5s. There'll be 10 questions and 1 bonus question. They're all worth 10 points. Some are easier than others.
For every single chapter, is gonna be on it.
Yeah.
Okay.
Example 12. There's cosine inverse of 1/2. So now it's the opposite, right? Which angle has a cosine value or x value of 1/2? And then you have to remember, where's cosine inverse, right?
Happening.
Yeah, I believe it's gonna be top half of the circle at pi/3, maybe?
We always have to look at the top right at the bottom.
Yeah, for cosine inverse, you only look at the top half. Since it's a positive half, it has to be this half.
Yeah.
If it's had sine inverse, you'd be looking at the right half.
Okay.
Same for tangent inverse. Those are defined over here. So if you had tangent inverse of -1, then you would get -pi4, which is this angle here. So you'd be going this negative direction. So if I have something basic like that, something just straightforward, give me the angle, cosine inverse of this, tangent inverse of something. Okay. Nothing insane. But if you haven't done 5-5, then please make some time.
You prefer the answers in radians or degrees?
Either way is fine, since,
So the answer would be 5-3.
yeah, it's 5/3. Since the question wasn't already in radians or degrees, you can choose. But if the question's already in radians, stick to radians. Okay. You guys have any questions about anything? All right, make sure you prepare a good formula sheet. Remember, no examples. And make sure you turn it in with your exam, or I'm not accepting your exam. Yeah.
So why would why was
Because it would be outside the domain. It is technically another option, but this function is restricted. Yeah, I think in chapter 6, that stuff will come up.